Hello, fellow code monkeys. I'm very happy and excited to have you here back again with me for another instance of the design pattern series. And this time we're going to talk about the pattern strategy. I think that the strategy design pattern is a very iconic design pattern. It kind of represents the whole family of design pattern. First, because it leverages one of the main idea on which design pattern or which many other design patterns are based, and also because it sheds some light on the famous design principle favor composition over inheritance. Well, the problem is that the favor composition over inheritance design principle can sound a little bit like a Zen proverb, vague, theoretical kind of wisdom. What does it mean, favor composition over inheritance? What's wrong with inheritance? Well, I think that the strategy design pattern clarifies extremely well what we mean with this saying, and it shows that there's some real, very concrete wisdom in this principle. So, without further ado, let's dive in the strategy design pattern. Actually, from now on, I'm trying to experiment with a different format for my videos. I'll try to make them smaller, so I'll break down a single design pattern in a few videos, because I think it's a better way to be more flexible, to keep your attention as well. I'll try to be as concise as possible, because, well, I know design patterns are super cool, but I'm sure, well, let's say I doubt that you want to spend most of your life hearing me babbling about design patterns. So let's go and try to be quick. In front of us we see the intent: define a family of algorithms, encapsulate each one, and make them interchangeable. Strategy lets the algorithm vary independently from clients that use it. Well, as usual, these descriptions are perfectly accurate and make a lot of sense for people who already know what we are talking about, but for people who are new to this stuff, maybe not so clear. And let's also give a look to the structure of the pattern. Here we see the UML diagram, and we can see there's some kind of composition going on. Here we can see there's a classical representation of composition in UML. And there's also some degree of actual inheritance going on here, because here we have like an abstract class or an interface that gets extended or implemented by a few other classes. So we can already see there's some composition and inheritance going on in this pattern. Here I have prepared a few code for you, a few lines of code, sorry. Because I wanted to set up a scenario, and the scenario is the following. We want to model one of my favorite sports, which is paddle. Paddle is kind of a tennis that's played in a box of plexiglass. Sounds crazy, but it's actually a sport that's a lot of fun. I'm very passionate about it, and as I say, when you want to do something, try to connect it with things that you already find interesting or fun, and to me, that's what I'm trying to do it here now, to make my work here with you even more interesting than usual. So we want to have a PadelPlayer. A PadelPlayer, as you see, is an abstract class and defines just two behaviors: defend and attack, because that's what paddle players do most of the time when they're playing paddle. And the thing is that I want to have different kind of PadelPlayer. For example, just to keep things very, very simple, I want to have paddle players that are more aggressive, that try to go for more, and players that tend to be a little bit more conservative, that are more careful and wiser, you may want to say. So, if you don't know much about the design patterns and there are no other requisites, I think you already know the answer. I can guess, I can see the answer that's coming up in your head. Well, yes, we have this abstract class. All we do is just to subclass it and create a couple of classes that are the AggressivePadelPlayer and the ManouveringPadelPlayer, which will give a definition of these two of these two methods, defend and attack, in order to comply with their style of play. And that's exactly what I'll show you now, because actually I think that the whole presentation on strategy is more instructive if you can see the naive implementation that you would do without strategy, and you can compare it with the more sophisticated strategy pattern implementation. So here you can see, for example, my aggressive PadelPlayer, which extends the class PadelPlayer. And as I promised, what does this guy do well is defining the attack method. So it's just writing something on the console. Then it's instantiating an object of type luck, because of course here there's some random numbers that are generated to establish if you make a good shot or a mediocre shot or a very bad shot. So without going too much into the details, here we see that we create this luck object, and then we want to look if your luck was favorable. Well, then what you do is that you obtain a player result, which is of shot quality winner and of aggressive style. These shot quality winner and aggressive style are instances of an enumeration that I will show you shortly. Then if your luck is average, you get a player result, which is strong and still aggressive because you're an aggressive player. And finally, if none of this is true, well, you end up making a very aggressive error. And here is the defending algorithm of the aggressive player. And here again, we instantiate an object of type luck. If luck is very favorable, well, an aggressive player can do winners even when he's defending. So, well, if you're very, very lucky, you might actually cut it and make a winner to brag about when you're defending. But if your luck is only favorable, well, then you make a strong defense, because you don't like to go for weak shots being an aggressive player. But the thing is that most of the time, when your luck is average, you try to go for more and you end up with a poor shot. So you will do an aggressive weak shot, and a lot of times you'll end up making an error. And the maneuvering player is pretty much the same, only that, as you can imagine, what will change is that when he's, for example, attacking, he will make a winner only if the luck is very favorable. But usually, when his luck is good enough to make a routine shot, he'll make a strong shot. And very rarely he will make an error, and all of these will be made with a style of play that's defined as careful. And here again, the method defend. With a reasonable luck, you make a strong defense, but most of the time, even if you don't have a reasonable luck, you still make a weak defense, and very rarely you'll make an error. Let's just give a look to the luck class, for example. As you could imagine, the luck class is just a kind of a very thin wrapper around the random object. And as you can see, what happens is that I generate a random number between a minimum and an upper bound, which are 1 and 101. So the end result is getting a number between 1 and 100. And then what happens is that I want to check with this method, luck is very favorable, luck is favorable, luck is average. If the number is, for example, bigger than 90, bigger than 70, as you can see, average luck means the result is bigger than 50, so it's going to happen on average half of the times. Reasonable has been defined as a result bigger than 30, and routine as a result bigger than 10. Another little particular that I want to point you out is that some of my classes are in design pattern behavioral strategy namespace, and those are luck, play result, which is of course a little class that encapsulates the shot quality and the style. As you can see, the shot quality is an enumeration which has the value error, weak, keep in play, strong, winner, and style is the aggressive and or careful styles of play. Play result, as I was saying, is the class that encapsulates one shot quality and one style. So it represents the end result of an attack or the end result of a defense from a player. It has a quality and a style to say if it was a very good shot or an error, and if it was made in the aggressive or defensive style. And these classes are kept in the main behavioral strategy namespace, while aggressive and maneuvering player I've put into this behavioral strategy, no strategy namespace, because of course, as I was saying before, now I'm showing you the naive implementation with subclassing. But in the next video we'll go over this and redo it. And since I want to leave you the code that I'm showing you now, I don't like it when people create code and then erase it or don't make it easily accessible to students. So I'll make sure that in the end we keep both the old implementation and the new implementation, of course in different namespaces. This was kind of a bit rushed, but because I don't want, as I told you, I'm trying to not to make you spend all of your life listening to me, but I think the idea is clear. I have an abstract mother class, PadelPlayer, with the method defend and attack, and every time I need a different kind of player, I make a subclass and I give an implementation for the two abstract methods. The rest is kind of details and funny play that I was doing with the LA class and the various style of play, stuff like that. Well, what's wrong with this? The answer is nothing. If the situation is that simple, inheritance and method override is perfectly fine. But you know, things are rarely this simple in real life. And I can foresee a couple of problems that we could have with this naive implementation. One is that, yes, inheritance is a very powerful tool, but exactly because it's so powerful, it establishes a lot of strong constraints. For example, every method that the child class inherits from the subclass, from a mother class, ends up being kind of a default if you don't override it. If the method is abstract, as in our class, it's okay, but what about if we have non-abstract method? Well, we could end up in a situation where you create a new subclass and you actually are not completely 100% conscious of all the methods that you are inherited from the superclass, and one of those methods actually doesn't make a lot of sense for this particular subclass that you are creating, but there's nothing to warn you against this, and so you run the risk of inheriting a method that doesn't really make any sense. I admit that this is kind of a corner case of a strange occurrence. The real deal breaker is a different one. The real deal breaker is when the requirement comes that your classes have to change their behavior during the execution of the program. So what I mean is that we end up with the requirement, which is actually kind of realistic, that our players do not play the whole match in the same style. And actually, a player that starts aggressive as the match evolves might need to have a different strategy. So he might have to calm down and play a little bit more conservative, or a conservative player might end up needing to exert a little bit more pressure. And I'm sure you can understand that this is not feasible in a reasonable way with just with inheritance and method override. Why? Well, because once an object is instantiated and it's an object of class aggressive player, there's no way to turn it into a maneuvering player. There's no way to change what methods will be called on this class. While we will see in the next video that leveraging the power of the strategy design pattern, we will actually be able to perform this kind of magic. And I think this is a good time to leave you with a little of curiosity, and I hope I'll see you all in my next video, where we are going to come up with a different implementation, with a different solution from this problem, but this time using the strategy design pattern.